For centuries, the steady beat of this brass bob has been our primary tool for dividing time into perfectly even intervals. This pendular motion is everywhere in the physical world, from the heavy, slow sway of a cathedral chandelier and even to the high-speed mechanical oscillations driving an antique pocket watch. This motion is so reliable that we've built our global standards of timekeeping around it. But why is this specific to and fro movement so predictable? It appears to be a perfect example of simple harmonic motion, the kind of ideal, repeating rhythm found in physics textbooks. However, the physical reality is actually mathematically messy, and making it work perfectly requires a clever approximation. To find the source of that rhythm, we look at a pendulum frozen at a specific angle, called theta. Gravity is the constant force here, pulling the bob straight down with a force equal to its mass times acceleration, or mg. Suspended at an angle,